Hello, in this video, I will explain to you on how to solve this problem from Halliday's book. So the question is, in figure 5.18, let the mass of the block be 8.5 kilogram and the angle theta will be 30 degrees. Okay, maybe let's write that first. Our mass of the block will be 8.5 kilogram and then the angle will be 30 degrees. Okay, so we'll have this given by the problem, and find the tension of the cord. Okay, so the tension of the cord will be this force here that goes there, right? So we will have this cord, the tension of this cord here, T, and then B, the normal force acting on the block, and the normal force is the force that goes there, right? So we will have this force here. This one will be our normal force. Okay, maybe let's denote that as N. Like that. And if the cord is cut, find the magnitude of the resulting acceleration of the block. Okay, so what is A if the T is gone, right? And that is the question B. Okay, maybe let's set the X and Y direction here as like this. So the x-axis is parallel to this one here, so I will have x goes there, but this y-axis goes perpendicular to this plane here, so I will have y-axis like that. Good. And now let's see what can we do from here. We have the mass here, and this is the normal force which is perpendicular to the plane. And then this is our tension of the cord, but then we also have the weight of the block here. Okay, and the weight goes down, right? Like that. And this is, let's name this one FW, the force by the weight of the block. However, it is not in the direction of X and Y axis. So we need to project it into X and Y axis. So we will have to project it into Y axis first here. Okay, so we will have this one here. And the trick is this angle is the same as this one. So this is theta. And so this force here is FW multiplied by the cosine of theta. Okay, and that is the projection for the y-axis here. But we can also project it for the x-axis here. Okay, and because this is cosine, in the x-axis, we will have sine of it, right? So let's just do it like that. So I will have the weight of the block multiplied by sine theta. Okay, now we have all the forces drawn and set. Okay, let's do it on the y direction first. Okay, maybe on the x direction or y direction is okay also. Okay, we will have the normal force here, the normal force on the positive direction, and then FW cosine of theta on the negative direction. So I'll have minus FW cosine of theta, and that will equal to the mass multiplied by the acceleration to the y-axis. Okay, but then on the y-axis it is not moving or stationary, so this is equal to 0 because of the stationary. It is not moving on the y direction. Okay, now we need to find out what is N, right? So we just leave it N here, and the weight of the block is the mass times the gravitational acceleration multiplied by cosine of theta here, and that will equal to 0. Now we can isolate N here, so we'll have mg and cosine theta. Good. And then we will have let's plug the values here. What is the mass? 8.5 kilogram. So we'll have 8.5 kilogram. And then G is 9.8. Okay. And then multiplied by cosine of theta. Theta is 30 degrees. Okay, and I think that will be the job of our calculator. So the normal force will be, let's do it by calculator. Where is my calculator? Okay, we can plug that in. I will have 8.5 multiplied by 9.8 and then multiplied by cosine 30 degrees, right? And that will be our normal force, which is 72.48. Okay, I will have 72 point what? 14, 72.14, and the unit here will be in Newton. Good, and maybe let's save that here. So this one will be our normal force, 72.14 Newton. Good. Now let's do analysis, but on the x direction. So now let's do on the x direction. Okay, and then remember the Newton's law. So we'll have the sum of the force on the x direction. That will be mass times acceleration. Okay, let's plug that in here. I will have on the positive direction, I will have this one here. The weight of the block, sine theta. And then minus t. And that will equal to mass times acceleration. But this will equal to 0, right? Because the weight is not moving. The block is not moving. So we'll have stationary. So the acceleration will be 0. Good. And now we will have on the right hand side, we will have 0 here. So we can isolate t here. So t is equal to Fw sine theta. But then Fw is just mg, the mass of the block, times gravitational acceleration and sine theta here. So we will have t here is equal to, let's plug that in, I will have 8.5 and then multiplied by g, 9.8, and then sine theta, I will have sine 30 degrees. Good, and I think that will be our calculator job here. So we'll have 8.5 multiplied by 9.8 and then multiplied by sine of 30 degrees. Okay, but be careful here, you have to set the calculator in the degrees mode. So we will have 41.65 Newton. 45.65, yeah, 65 Newton. And that is the value of t here. So we will have 41.65 Newton. That is our t. Good. And then we have answered the first two questions. The tension is this one. So that is question A. This is the answer. And the normal force, that will be our B answer here. And now let's work on C. If the cord is cut, find the magnitude of the resulting acceleration. Okay, maybe let's clean our slide first. Okay, now if the cord is cut, if the cord is cut, okay, if the cord is cut, we don't have this force here, right? So there will be no force here. That will be, and the only force working on the x direction is Fw sine theta. So we will have the sum of the force on the x direction is not 0 because the block starts moving, right? And the only force that work on it is Fw sine theta. So we'll have Fw sine theta here, and that will equal to m multiplied by a. Okay, let's plug that in. So the weight of the force will be the mass times gravitational acceleration sine theta, and then mass times acceleration. But we cancel out the mass here, right? We can divide both sides by m, and then we can just calculate a. So a is just g sine theta. So let's plug in the value here. So we will have 9.8 multiplied by sine of 30 degrees. So what is a? Let's plug it into calculator. 9.8 multiplied by sine and then 30 degrees. Okay, we'll have 4.9. So we'll have 4.9 meter per second squared. So that is the answer for C. So we'll have C here. That will be 4.9 meter per second squared. So we have answered the question. This is the answer of question A. This is the answer for question B, and this is the answer for question C. Hopefully I did not make any mistakes in my calculation. Thank you for watching. See you in the next video. Bye bye.